Welcome to The Explainer. Today, we are going on a journey deep inside a factory to uncover the secrets behind the batteries that power, well, pretty much everything in our daily lives, from the raw powders that start it all to the final powerful cell.
So before we really dive in, let's just start with a question. Have you ever stopped to think about the insane amount of engineering that's packed inside the thing that powers your phone? It's truly a marvel of chemistry and precision manufacturing.
All right, so here's the game plan for our factory tour. We're going to follow a battery's creation right from the raw stuff, through assembly and its big awakening, all the way to the final tests.
Okay, let's kick things off with the big picture. How these things actually come to power our world. The entire manufacturing process, this unseen engine, it all really boils down to three main stages.
And look, every single lithium-ion battery, I don't care what shape or size it is, it goes through this exact, super-controlled three-part process. It's basically the fundamental recipe for making portable power.
All right, time to get our hands dirty. Metaphorically, of course. We're diving into the first and, honestly, the most critical stage, creating the very soul of the battery, the positive and negative electrodes. This is where the magic chemistry starts.
And this isn't just one step, it's a 5-part dance of incredible precision. You've got mixing, coating, drying, calendaring, and slitting. Each one has to be perfect, because if you mess up one, the whole battery could be a dud.
So it all kicks off by mixing this, well, you can think of it as a chemical batter. It's called a slurry. And the goal here is just perfect, total uniformity. Any clumps, any little inconsistencies, that's going to come back to haunt the battery's performance and how long it lasts.
Okay, so once that slurry is perfect, it gets coated onto two different kinds of metal foil. It's this continuous roll-to-roll process. You've got the anode, that's the negative side, which gets coated on copper foil. And then the cathode, the positive side, that goes onto aluminum foil.
Now this next part, calendaring, is probably my favorite analogy. It's literally like running fresh pasta dough through one of those rollers. These coated foils are squeezed through massive, high-pressure cylinders that compact the material. Why? To literally pack more energy into a smaller and smaller space. It's all about that energy density.
Okay, so our electrodes are mixed, coated, and pressed. They're ready to go. The next big phase is to actually assemble them into the core architecture of the battery cell. This is where all those individual pieces finally become one single unit.
And there are really two main ways to do this. You've got winding, which creates that classic jelly roll you find in cylindrical cells, like for power tools. But for the flat pouch cells like the ones in our phones, it's all about stacking. You layer individual sheets to use every last bit of space super efficiently.
So you've got these three key assembly steps. You're combining the anode, the cathode, and that crucial separator sheet in between. Then you're welding on these teeny tiny connection tabs. And finally, you're packaging the whole thing up. And let me tell you, this has to be done with surgical precision. Even a microscopic tear in that separator could cause a major short circuit. No pressure, right?
All right, now for what I think is the most dramatic part of this whole journey. The cell's all put together, it's filled with electrolyte, but right now it's basically a paperweight. It's totally inert. It is time to bring this thing to life.
And this is way more than just plugging it in. We're talking about a very slow, incredibly controlled process called formation. This very first charge is what literally activates the cell's chemistry. It is absolutely vital for the battery's future health and, of course, its safety.
See, during formation, something really incredible is created. It's called the SEI layer. As that battery charges for the very first time, this microscopic shield actually grows on the anode surface. And that little shield is what's going to protect it from breaking down over thousands and thousands of future charge cycles.
And get this absolutely critical step, the formation process, it can take up to 3 full days. Yeah, that just shows you the kind of time and investment it takes to make a battery that's not just powerful, but also safe and durable.
Okay, let's head to the final stage. Every single cell is now fully formed and alive. But before it can ever think about leaving the factory, it has to pass a whole gauntlet of tests. This is like the final exam, and it is tough. And they test for everything. Does it hold the right voltage? Check. Can it actually store the amount of energy it's supposed to? Check. And the big one, can it handle extreme conditions without, failing spectacularly? It's all about those critical safety checks.
So, based on how they do on that exam, the cells get sorted into different grades.
Only the absolute best performers, the grade A cells, get to be grouped together in a high-end battery pack. This is super important because it makes sure every single cell in that pack is going to behave in exactly the same way.
You know, at the end of the day, this whole final exam process, it's the manufacturer's promise to you. It's their guarantee of safety and reliability. It's the reason you can trust that little power plant you carry around in your pocket every single day.
So from a simple chemical slurry all the way to a powered-up, fully graded cell, we've seen just how complex and precise this whole journey is. And that leaves us with one final big question. With a process this intricate, what on earth happens when we start to fundamentally change the recipe, when we start introducing entirely new materials and battery chemistries into the mix?